Okay, so this is the vector equation of the line in 3 dimensions. So we have a point which is 2, 5, minus 1, and the line is going in the direction so that the line also goes through the point 4, 1, 7. I hope you can see that that means that this is the vector from the first point to the second point. So we can immediately write the vector equation of the line as a position vector of anywhere on the line is 2, 5, negative 1 plus lambda 2, minus 4, 8. So lambda, remember, is that parameter. So lambda is a parameter. If we made lambda 0, we'd have the point 2, 5, minus 1. If we make lambda 1, that will get us to the point 4, 1, 7. If we make lambda equal to a half, then what we're going to get is that r will equal 2, 5, minus 1 plus 1 minus 2, 4, which will give us 3, 3, 3. And I hope you notice that 3, 3, 3 will be the midpoint of these 2 points. So any lambda will give us somewhere on this line. If we made lambda equal to 2, it would get us here. If we made lambda equal to minus 1, it would get us somewhere here. If we make lambda equal to pi over 2, it will be somewhere in here. So any value of lambda will give us somewhere on the line. Now, so that's fine. And that's almost identical to the 2-dimensional one. But now we can write it in parametric form. So the position vector is x, y, z. We still have the same vectors for the line. So we now get x equals 2 plus 2 lambda, y equals 5 minus 4 lambda, and z equals minus 1 plus 8 lambda. Now we can now write equations that are equal to lambda. So lambda equals x minus 2 over 2, but it also equals y minus 5 over negative 4, but it also equals z plus 1 over 8. Notice how I've left the minus 4 as minus 4 there. And the reason I've done that is so that then I can see the direction of the line. So that 2 minus 4, 8 is the direction vector of the line. Now, this is now the Cartesian form of the line. And what I want you to notice is we've got 3 parts that are all equal. So if we know the value of x, that's going to tell you the value of y, and that's going to tell you the value of z. If we know the value of y, we know the value of x, we know the value of z. For each value of either x, y, or z, there is only one other value of y, or z, or x, whichever one we're missing. So this is now the Cartesian form of the line. So this is the vector, this is the parametric, and this is the Cartesian form of the equation of a line. Where do we go next? Well, let's have a look at the equation of a plane, but that's another time.